Hello guys and welcome in this lecture. We're going to talk about ELCB or earth leakage circuit breakers. Now in order to understand ELCB we need to step back and look at how a voltage source and a load are interconnected with each other in three-phase AC system. Assume that on the left hand side we have an AC power generator. And this one, let's say it's coming from the energy company. And let's say that this power source is interconnected with your electrical panel here on the right hand side. And this type of configuration is called the star-to-star connection. This configuration here is overly simplified, but it will give you an idea on how the ELCB works. Now let's say that we started generating power. We will have three currents going through the three phases, all the way to the load or to your electrical panel. Now as we can see, the three currents are meeting at a joint point. And the question is, where will all of these currents go? They should be combined in a place and sent back to the voltage source in order to complete a full circuit. And here comes the objective of a neutral. It will carry back all the phases currents to the voltage source. And the relationship between the neutral current and the phases current in this star-star configuration is I1 plus I2 plus I3 will equal to the I neutral. And as you can see, the neutral has a low impedance path, and it's an easy path for the current to go and propagate back to the voltage source. I mean, there is no load passing through it. It's just a plain wire connecting these 2 points. Now, if we can measure the current going to our load through the three phases and measure the current propagating back through the neutral current and compare the two values, they should always be equal. However, if they're not, then there is a problem. And this is the principle of ELCB circuit breakers. It compares those two currents. If they are not equal, then the circuit breaker will trip. But this raises a question of, well, how can these two currents not be equal? Where will this difference come from? And the answer is earth leakage. But what is earth leakage? Let's go through the concepts that will lead to the understanding of earth leakage. Currents loves paths with low impedance, meaning it will go to the path that has the least resistance. Meaning if the current found two ways, one of them with a load and one of them without a load and just a plain wire, it will choose to go with the plain wire route. So in this circuit right here, the current is flowing from the phase to the load to the neutral and coming back. And the current is equal at all the points in this circuit. Now if we short circuit the phase and the neutral like this, and according to the rule we've learned, all the currents or almost all of it will go through this short circuit. And since there is no load, a huge amount of current is going to propagate back to the neutral. This is not earth leakage, this is just a short circuit. So still the current going to the phase is the same as the current going through the neutral, even though it's now much larger in magnitude. But this will help us to understand this scenario. If a human being touches this phase and he's standing on the ground, he will act as a short circuit with the ground. So all the current will go through his body to the ground. And the small or no current is going to propagate back to the neutral. So right now, you have the current going through the phase is not equal to the current propagating back through the neutral, since a huge amount of it is propagating to the ground right now. And here is an additional information. A huge voltage drop is going to be applied between you touching the phase and you touching the ground, and this voltage drop will cause an electrical shock. So now that we understand what is earth leakage, let's see how we can prevent it from happening using ELCBs. Let's say we have a small electrical panel and we are using an MCB as an input circuit breaker. This input circuit breaker is going to be connected in series with ELCB. And the ELCB is the one that's going to distribute power to your load. Now we will take the neutral of this electrical panel and we will feed it to the ELCB. So as you can see, the load is taking current from the three phases and it's giving the current back from the neutral. Now if the current coming back from the neutral is not equal to the sum of the three phases, the ELCB is going to trip. And these devices are very sensitive and they can sense down to 30 milliamps. And if you are buying an ELCB, try to make sure that the rated current of it is matched with the input circuit breaker, because there is a current capacity for these ELCBs that can handle. Now, an important information. In the old ELCB, there was a voltage-based protection and a current-based protection. They diverged and they formed RCCB for the current, and there is a few other more for the voltage-based protection. But ELCB is the mothership of these two diversions. Now let's Google and check what types of ELCBs are there and how we can read their datasheet. So notice that if we write ELCB from Schneider, we'll see results about RCCB. However, the same operation principle holds. Let's click on the RCCB. Let's choose a 40 amps rating. And here we can see IN, the rated current is 40 amps, and it's an AC type, and the earth leakage current sensitivity is at 30 milliamps, which is a very small leakage current.